Welcome to the deep dive.
Yeah.
You're curious, right? You want to know what's happening out there, but maybe without drowning in just endless information.
Yeah, there's a lot going on.
Perfect. Think of this as your express lane, your shortcut to understanding the really exciting recent stuff in space. We've got you covered.
Exactly. We've been, digging through everything that's been happening in space over the last few months. We're talking the second quarter of 2025. So March, April, May.
Right.
That means looking at space news, research reports, the whole lot, really, to pull out the really fascinating developments for you.
So, yeah, no need to feel like you're behind on the cosmic headlines. We're pulling out the significant bits, the intriguing stuff, those aha moments, but without the brain melt.
Consider it your quick way to get up to speed.
We want you to connect the dots, see the bigger picture of what's unfolding up there.
Mm-hmm.
Okay, then. Let's unpack this cosmic canvas of Q2 2025. And, well, it's hard to ignore, isn't it? A lot of the action seems focused on one place.
Yeah. Oh, absolutely. It really feels like a global moon rush is on.
Right.
Yeah, the ambition, the sheer level of activity targeting the moon right now is, well, it's quite something. We're seeing big steps from government programs. The commercial side is really hitting its stride. And international cooperation is just becoming more and more key.
Okay, so let's start with NASA's Artemis program. It really feels like they're, laying the groundwork, putting all the pieces in place for getting crews back there.
That's definitely the big story for Artemis this quarter. The focus has been squarely on nailing down the hardware, the procedures, everything for Artemis II, the mission that's actually going to send astronauts around the moon first.
Right. We saw that big step back on May 1st, joining the SLS rocket's upper stage with the core stage and the boosters. That's literally monumental, isn't it?
It really is. That upper stage, the interim cryogenic propulsion stage, the ICPS, that's basically the powerful final kick that sends Orion off towards the moon. Yeah. Getting it all integrated in the VAB, the Vehicle Assembly Building at Kennedy, it means they're one huge piece closer to having the full stack ready. It's all about making sure every single part plays together perfectly before you put people on top. It's methodical.
And speaking of Orion, the spacecraft itself had a busy time. Moved to the fueling facility, I think May 3rd. That sounds like things are getting serious.
Oh, yeah. Fueling is definitely a major milestone. It means the spacecraft's core systems are pretty much set, ready for loading the propellants. Hazardous stuff, but essential.
Right.
It's one of the last really big steps before it gets stacked onto that giant SLS rocket.
And you can't talk crew missions without the crew.
Mm-hmm.
Reed Wiseman, Victor Glover, Christina Koch from NASA, Jeremy Hansen from Canada.
Yeah.
They were deep in simulations, weren't they? Practicing entry, launch.
Everything.
Even suit fit checks. It really makes it feel tangible,
Absolutely. Having the astronauts spend so much time in those high-fidelity sims is just crucial, both for mission success and obviously for their safety. They run through everything, normal ops, what-if scenarios, emergencies. It builds that muscle memory, that confidence. And yeah, seeing them getting fitted in those iconic orange Orion suits, it's a powerful reminder that actual people are gearing up for this incredible trip.
And there was progress on Artemis III, too, the actual landing mission. The core stage got its thermal protection coating. Sounds technical, but pretty fundamental, I imagine.
Oh, absolutely fundamental. Yeah. That coating, it's basically a high-tech shield, protects that massive core stage from the intense heat during launch as it punches through the atmosphere. Critical layer of defense. Can't have it buckling under the stress.
And it's not just NASA, is it? We saw another international deal for a CubeSat, a small satellite, to hitch a ride on Artemis II. Really shows how many players are involved.
Yeah, and that's really interesting strategically. NASA's approach now heavily involves both international partners, like with the CubeSat, and commercial companies.
Right.
It's not just a government show anymore. By bringing others in, they're aiming for, a more sustainable, more broadly supported lunar program for the long haul. It's a smart shift.
That leads us perfectly into the next bit. Commercial Lunar Payload Services, or CLPS, feels like that initiative where NASA basically hires private companies for moon deliveries is really starting to show results.
It absolutely is. This quarter saw a really significant win with Firefly Aerospace's Blue Ghost Mission 1. The fact they successfully demonstrated NASA's electrodynamic dust shield tech right there on the lunar surface, that's a major achievement.
Lunar dust sounds minor, but I keep hearing it's a massive headache up there.
It's a huge problem. It's incredibly fine, like talcum powder, but super abrasive because it's basically tiny shards of glass and rock. It gets everywhere, sticks to everything, gums up mechanisms, scratches surfaces.
Nasty stuff.
Yeah, and potentially a health hazard for astronauts, too. So proving this electrodynamic dust shield, the EDS, which uses electric fields to, actively repel the dust, actually works on the moon. That's a huge step for longer missions. Remember, this mission launched back in January, landed around March 2nd in Mare Crisium, so getting this data back was key.
And this success came not long after Intuitive Machines had their successful landing, too.
Yeah.
It really seems to be proving the CLPS model works, doesn't it? NASA outsourcing the delivery part.
Exactly. Having multiple CLPS providers now successfully reaching the moon, it shows the model can deliver. It offers more frequent, potentially much cheaper access to the lunar surface.
Right.
It's fostering this whole commercial lunar economy, letting NASA focus on the big Artemis human missions while these companies test tech, do science. It's a win-win. And the cost effectiveness isn't just upfront savings for NASA. It helps de-risk tech because commercial partners can iterate, maybe even fail sometimes, learning lessons that ultimately strengthen the whole Artemis path.
Now, zooming out a bit. The U.S. isn't alone in this moon focus. What were the big international moves this quarter?
Oh, the global interest is undeniable. China's Change program, for instance, just keeps racking up achievements. The Chang'e 6 lander, the one that brought back samples from the far side, a historic first, it marked its first full year of operation on the surface on June 1st.
Wow, a full year on the far side. That speaks volumes.
It really does. Shows the durability, the capability of their technology. Then you have Japan. JXA's president, Yamakawa, made comments about being open to supporting potentially lower-cost U.S. lunar missions.
Interesting.
Yeah, they're already heavily involved in Artemis, providing astronauts, working on that Toyota rover. But it shows their adaptability, right? They're committed but pragmatic, looking at different ways to collaborate as the landscape evolves.
And the UAE, the United Arab Emirates, they're really pushing forward, too, partnering with Firefly for their Rashid 2 rover, aiming for the far side in 2026.
Yeah, and their goals are ambitious. Testing lunar mobility, how materials hold up, even looking seriously at in-situ resource utilization. ISRU using lunar resources on the spot.
ISRU, right. Living off the land, essentially.
Pretty much. The UAE targeting the far side, testing these advanced technologies needed for sustainable presence. It just shows how widespread these ambitions are now. It's not just about flags and footprints anymore. It's about building capabilities for the long term.
It really paints a picture of a truly global push, doesn't it? So many different countries, different approaches, all aiming for the moon.
Absolutely. And it's this fascinating mix of, competition and collaboration playing out. Every nation has its strategic drivers, sure, but there's also this growing realization that partnerships are powerful, sharing the costs, the technical expertise, even the risks involved. It just makes sense.
Yeah.
So the lunar landscape is getting much more diverse, more players than ever, which is exciting, but also brings, some complex diplomatic stuff to navigate alongside the engineering.
Okay, from one world to another, let's turn our eyes to Mars. Feels like our robot explorers there are constantly turning up new clues, new mysteries about the red planet's past.
They certainly are. Perseverance and Curiosity, our main rovers on the surface, continue to be incredibly productive. And yeah, Q2 2025 brought some really significant finds from both.
Perseverance and Jezero Crater, finding unexpected minerals. Kaolinite and spinel in those pale rocks doesn't sound like typical Mars rock.
That's exactly right. Finding these is pretty significant because on Earth, kaolinite especially often forms where there's been a lot of interaction with water, sometimes warm water, hydrothermal activity even.
Okay.
So finding it in Jezero suggests that crater might have had a more complex, maybe more habitable past than we even realized. Maybe not just a lake bed, but something more dynamic. And they've cataloged thousands of these rocks, over 4,000. It's really shifting our picture of early Mars.
And kaolinite can trap water in its structure, right? That's kind of tantalizing. Maybe ancient water is still locked away down there.
Exactly, that water binding ability. It raises the very exciting possibility that maybe substantial amounts of Mars's ancient water could still be there, locked in subsurface deposits. Big implications for how long Mars might have been habitable and, the potential for finding signs of past life deep down.
Meanwhile, Curiosity over in Gale Crater sent back those amazing images of polygonal fractures, Like cracked mud, but on Mars, yeah.
Yeah, really well-preserved polygonal patterns. Scientists think they could be from repeated cycles of freezing and thawing ground ice, maybe billions of years ago, or possibly even ancient tectonic stresses.
Okay.
Either way, they're like frozen clues about Mars's ancient climate, its geological history, really cool features.
And it wasn't just geology. We also heard about finding organic molecules
Yeah.
described as unprecedented size. That sounds important.
It is important. Now, we always have to add the caveat, organic molecules are not proof of life.
But they're the building blocks.
Exactly. They're the necessary ingredients. Finding complex organics like this just strengthens the case that ancient Mars had the raw materials, the right chemistry, for life to potentially get started.
So we've got multiple lines of evidence now from different locations.
Yeah.
Past water, interesting minerals pointing to maybe warm water, complex organics. It feels like the picture of a potentially habitable early Mars is getting sharper.
Precisely. The converging evidence from Perseverance, from Curiosity, across different regions, it strongly suggests Mars wasn't just, briefly damp. It likely had varied, possibly long-lasting watery environments.
Right.
So the science focus is really honing in now on the duration and the characteristics of those ancient habitable niches, which of course makes the upcoming Mars sample return missions even more critical. Getting those rocks back here to study in labs on Earth, that could give us definitive answers.
Speaking of future missions, ExoMars, the Rosalind Franklin rover, that seems to be moving forward, with ESA and NASA collaborating strongly.
Yeah, it's a major international effort. NASA's providing some really key pieces: the launch vehicle, crucial parts of the landing propulsion system, essential heaters to keep the rover warm enough to work.
Because Mars is cold. Really cold.
Extremely cold. So yeah, this collaboration just highlights how these big, complex missions often need that international teamwork.
And Rosalind Franklin has that deep drill, doesn't it? Can go down, 2 meters?
Up to 2 meters, yeah. That's the key capability. The idea is to get below the surface, below where harsh radiation has been zapping everything for billions of years.
Right, to find better preserved stuff.
Exactly. To access material that might hold well-preserved organic molecules, maybe even chemical biosignatures of past life, protected from that surface radiation. The current plan is launch in October 2028, landing November 2030. Fingers crossed for that one.
And China's Mars ambitions are still very much alive, too. Tianwen-2, even though it's mainly an asteroid sample return mission, it feeds into their Mars plans, right?
Absolutely. Tianwen-2, launching late May 2025, hopefully, is primarily about grabbing samples from a near-Earth asteroid and bringing them back. But
the tech is transferable.
Exactly. It's a crucial demonstration of complex technologies: rendezvous, docking deep in space, sample collection, containment, return, all directly applicable to their future, more ambitious Mars sample return goals. It's a very methodical, step-by-step buildup.
And their long-term vision, aiming for a crewed orbital mission around Mars by 2050, developing the big rockets, the crew capsules needed for that.
Yeah, their commitment seems clear. They're developing the Long March 10 heavy lift rocket, the Mengzhu crew spacecraft. It's all happening in parallel. They're clearly leveraging everything they learned from their successful moon program to pave the way for Mars. It's incredibly challenging, but they're laying the groundwork.
So it looks like the focus on Mars is really shifting, isn't it? Not just understanding the past, but actively planning for sample return and eventually humans. It's a long game.
It is a marathon, definitely not a sprint. But yeah, the next decade or so will be heavily focused on sample return, both the NASA's effort and China's plans. And in parallel, developing the technologies for human missions, Mars is definitely seen globally as a key long-term destination.
Okay, we've hit the moon and Mars, but the solar system's a big place.
Yeah.
Let's talk about venturing even deeper. What other missions caught our eye in Q2?
Oh, several really exciting ones are making progress. NASA's Dragonfly mission to Titan, Saturn's biggest moon. Oh, it's so cool. Revolutionary rotorgraph design.
A drone on Titan. It still sounds like science fiction. What's it hoping to find there?
Its main goal is to explore Titan's unique environment. It's rich in organic molecules, has lakes and rivers of liquid methane. It's just wild.
Wild is right.
So Dragonfly will investigate its prebiotic chemistry, the stuff that could lead to life, assess habitability, look for chemical biosignatures. Just imagine this quadcopter flying over dunes, through clouds, maybe methane rain. It's going to be incredible.
Closer to home, NASA's MU's mission, the Multi-Slit Solar Explorer, passed its critical design review. Sounds like we're getting a new eye on the sun.
That's right. Passing the CDR is a huge hurdle. Basically means the design is solid, ready for construction. MUSE launches in 2027, hopefully. It'll give us these unprecedented high-res views of the sun's corona, its outer atmosphere.
To figure out why it's so hot.
Exactly. That's a major solar mystery, why the corona is millions of degrees hotter than the surface. MUSE will also help us understand the origins of space weather, solar flares, that kind of thing.
And the Nancy Grace Roman Space Telescope also hit a milestone. Finished its thermal vacuum testing. Must be a relief for the team.
Oh, huge relief. Thermal vac testing is brutal. Simulates the extreme heat, cold, and vacuum of space. Got to make sure everything survives and works. Roman's going to be amazing for studying dark energy, dark matter, finding exoplanets, a real powerhouse.
And JXA's MMX mission Martian Moons Exploration also went through crucial thermal vacuum tests. Seems like a common theme, making sure these things can handle space.
It's absolutely vital, yeah. Especially for deep space missions. MMX launches late 2026, aiming to grab samples from Phobos, one of Mars's moons, and bring them back by 2031.
Samples from Phobos. Why is that important?
Scientists hope those samples will finally tell us where Mars's moons came from, where they captured asteroids, or formed from Mars itself. It could also shed light on the early solar system's formation.
So whether it's flying a drone on Titan, staring at the sun, probing dark energy, or grabbing moon rocks from Mars, it really feels like these deep space missions are all tackling fundamental questions, aren't they? About origins.
Exactly. That's the strong connecting thread. Dragonfly and Titan's chemistry, MUSC and the sun's workings, Roman and cosmology, MMX and Phobos' origins. They're all pushing our understanding of how planets form, the conditions for life, and ultimately our place in this huge cosmos.
All right, let's bring our focus back closer to home now. Low Earth orbit, the International Space Station, China's Tiangong. Still a lot happening up there.
Absolutely. LEO is still a really busy place. Science, tech development, international crews. The ISS remains incredibly valuable, even as we look towards commercial stations taking over eventually.
We saw a crew swap on the ISS in April. Don Pettit from NASA and some Roscosmos cosmonauts came home after, 7 months?
7 months, yeah. A long stint. Those long-duration flights are just vital for understanding how space affects the human body over time and for doing research that needs that microgravity environment.
Right. And then soon after, a SpaceX Dragon cargo ship left, bringing back science samples.
Yep, undocked late May, packed full of results. Things from the MISSIC experiments, that's materials on the ISS.
Testing how stuff holds up in space.
Exactly. Plus results from some debris capture tech tests and even materials from the Storytime from Space Educational Program really shows the variety of work happening up there.
It really does. The ISS is just this unique laboratory, isn't it? Material science, human physiology, education, all happening side by side. And getting those samples back to Earth labs is key.
Crucial for analysis, yeah. Leads to new discoveries, new tech.
Looking ahead for ISS, Axiom Mission 4 is coming up. The next private astronaut trip, commanded by the legendary Peggy Whitson. And a very international crew, right? India, Poland, Hungary involved.
That's right. AXA 4 really highlights that growing commercial use of the ISS and the global interest in getting access to space. They'll be doing their own research up there. And then later in the summer, NASA's SpaceX Crew 11 is scheduled with crew from NASA, JXA, Japan, and Roscosmos. So that international partnership continues strong on the government side, too.
And the science keeps pushing boundaries. ESA and Airbus 3D printing the first metal part in space. That sounds like a big step.
It's a really significant milestone for in-space manufacturing, or ISAM, being able to print metal parts on demand in orbit, think about repairs, or even building larger structures without having to launch everything from Earth. It could be a game changer for long-duration missions or habitats.
Yeah, huge potential. And Redwire got another NASA contract for pharma research using their pillbox facility to grow crystals. Microgravity must offer real advantages there.
It often does. For certain proteins, you can grow larger, more uniform crystals in microgravity than you can on Earth. That helps scientists understand their structure much better, which is key for designing more effective drugs. So yeah, it highlights the potential for doing certain high-value research in space.
Okay, now let's look at China's Tiangong space station. Also very active. The Shenzhou 20 crew arrived in April. Did their first spacewalk in May.
That's right. Their arrival keeps China's continuous human presence going in Laleo. And that first EVA, or spacewalk, was a big one, about 8 hours. Taikonauts Chen Dong and Chen Zhongru were installing debris shields, doing maintenance, inspecting equipment.
Debris shields, interesting. Shows they're planning for the long haul.
Absolutely. It demonstrates their growing expertise in operating and maintaining a large orbital outpost. This was actually the 19th EVA from Tiangong, or the 21st Chinese spacewalk overall. They're building experience fast.
And they keep emphasizing Tiangong is designed for continuous occupation for at least a decade. They launched a new crew just before Shenzhou 20 arrived. It really shows their commitment.
Yeah, the design for long-term presence, the regular crew swaps, the ongoing upgrades like those debris shields, it all signals China's steady, determined progress in building a very capable, independent space station.
So we've got this picture emerging. The ISS maximizing its final years as a research platform and a testbed for commercial LEO ideas, while Tiangong steadily builds its own operational capacity. Feels like the future of LEO is multiple platforms, doesn't it?
Precisely. We're moving towards a future LEO environment that's likely a mix. Maybe evolved government platforms from the ISS model, commercially owned stations, and state-run stations like Tiangong, all pursuing, potentially distinct but also sometimes overlapping goals, science, tech dev, commercial activities. It's going to be a different orbital landscape.
Okay, let's dive into some of the really mind-bending stuff now, the big scientific breakthroughs, peering deeper into the cosmos thanks to our amazing telescopes.
Yeah, this was an exceptionally rich period for astronomy. JWST, the James Webb Space Telescope, just keeps delivering revolutionary data. But Hubble is still contributing significantly, and LMA too.
JWST. First evidence of cloud convection on Titan. And finding a key carbon molecule. That moon just gets weirder and more interesting.
It really does. Cloud convection suggests an active weather system, likely part of its methane cycle, and that carbon molecule adds another piece to the puzzle of its complex, potentially prebiotic atmosphere. It's a fascinating place.
And it didn't stop there. JWST images of Jupiter's auroras, hundreds of times brighter than Earth's, and the first ever images of Neptune's auroras.
Incredible views, giving us unprecedented insights into the magnetic fields, the atmospheric processes of these giant planets, details we just couldn't see before.
Zooming way out, JWST finding evidence for a supermassive black hole in Messier 83 using ionized neon. Sounds like cosmic detective work.
It is. Detecting that highly ionized neon signature is a powerful way to pinpoint an active galactic nucleus. The bright core, powered by a supermassive black hole, helps us understand how these monsters influence galaxy evolution.
And the most detailed image ever of the planetary nebula NGC 1514. Dying stars put on quite a show.
They really do. JWST's infrared vision revealed these intricate dusky rings, the ejected material, gives us a much deeper look at how stars like our sun end their lives.
But maybe the most stunning stuff from JWST is about the very early universe. That galaxy, JD's JSC 14-0, finding it was surprisingly bright and already had oxygen when the universe was less than 300 million years old. That messes with some theories, right?
Oh, absolutely. Finding heavier elements, what astronomers call metals, like oxygen that early, is a real challenge to current models. It suggests the first stars might have formed, lived, and died, enriching the cosmos much faster than we thought. And finding bright hydrogen emission from another very early galaxy. It's forcing a rethink of the whole cosmic dark ages period. JWST is genuinely rewriting the first chapters of cosmic history. It's incredible to watch.
And good old Hubble is still plugging away too, right? Still valuable.
Absolutely. Hubble's visible and UV observations are still incredibly valuable, complementing JWST perfectly, capturing beautiful images like some highly inclined spiral galaxies recently. It's still a workhorse.
And LMA, the Atacama Large Millimeters of Millimeter Array, peering into the cold universe.
Yep, LMA is crucial for studying the cold gas and dust where stars and planets form. It measured the evolution of a massive barred spiral galaxy way back in the early universe, mapped lots of protoplanetary disks near our galactic center, stuff other telescopes can't see.
It's like they're all pieces of a bigger puzzle, giving us this multi-wavelength view.
Exactly, that synergy is key.
And let's not forget exoplanets. TESS, the Transiting Exoplanet Survey Satellite, and follow-ups. Feels like we're finding new worlds constantly.
The pace is just phenomenal. Just this quarter, TOI 276E, a super Earth in a young system, TOI 5573b, Saturn-sized around a small M dwarf, BD plus 054868AB, a planet literally disintegrating, leaving a tail.
Wow, a disintegrating planet.
Yeah. And GJ 3998D, a super Earth in the habitable zone of a red dwarf, potential new planets around nearby Barnard's star, even a candidate planet in a polar orbit around a brown dwarf binary.
Okay, that's a lot. The diversity is just staggering.
It really is. Underscores the incredible variety of planetary systems out there.
So All these telescopes working together, challenging standard models, giving us these amazing new views. It really feels like a golden age for astronomy.
It absolutely is. The combination of these advanced observatories is providing this multifaceted view, leading to really significant shifts in our understanding of fundamental cosmic processes. It's not just incremental progress, it's transformative.
All right, let's tackle some of those really big mysteries. Dark matter, dark energy, the stuff we know is out there but can't quite grab hold of.
Still some of the biggest puzzles in cosmology, yeah. But Q2 saw some intriguing ideas floating around.
Like that novel theory for dark matter, suggesting particles started fast, then slowed down and gained mass. That sounds different.
It is quite different from the standard cold dark matter picture where the particles were always slow moving. This proposes a different origin story, a different way dark matter got its gravitational clout to shape the universe's structure. Still very theoretical, of course.
And dark energy, the thing speeding up cosmic expansion, results from DI, the dark energy spectroscopic instrument, hinting it might not be constant. Its influence might have changed over time.
Yeah, those hints are potentially huge. The standard model assumes dark energy is a constant, Einstein's cosmological constant. If DI's results hold up and show it has evolved, well, that forces a major rethink of the universe's ultimate fate and the fundamental physics behind expansion. Big if still, but very tantalizing.
Moving beyond the invisible, gravitational waves. LIGO, Virgo, KAR hit their 200th candidate detection in this observing run. That's incredible progress.
It really is. To surpass the total from the first 3 runs combined already in this 4th run, it just shows how much more sensitive the detectors are now. Gravitational wave astronomy is rapidly maturing into this powerful new way to listen to the universe's most violent events, like black hole mergers. They've logged about 290 candidates in total now, across all runs.
Space-time ripples. Amazing. And fast radio bursts, FRBs. Still mysterious.
Oh yeah, still deeply mysterious. Those super brief, super powerful radio flashes from other galaxies. JWST might have found some infrared counterparts to one, FRB 2250303009, which is crucial for tracking them down.
Okay.
And another one, FRB 22150209A, was traced to an old dead elliptical galaxy, which is weird because we thought they might come from more active younger environments like magnetars. So multiple ways to make FRBs we just don't know yet.
Still lots to figure out there. Even supernova exploding stars keep surprising us, right? Amateurs finding new ones, and that study suggesting past supernovae might have caused mass extinctions on Earth.
Yeah, supernovae are fundamental. They create and spread heavy elements. But the idea they could directly impact life on Earth through radiation or cosmic rays, that adds another fascinating dimension to their study. And yes, amateur astronomers play a huge role in spotting these transient events. We saw reports of SN 2025 AMPRA, IQW, KFM at WOHEM just this quarter, triggering professional follow-ups.
Closer to home, astronomers found a huge nearby molecular cloud we hadn't seen before, like a hidden star factory.
Exactly. These giant clouds of cold gas and dust are where stars are born. Finding a big one relatively close gives us a great local laboratory to study those very first stages of star formation in detail. And related research suggests that it's not just how much gas a galaxy has, but how it's distributed that really drives how efficiently stars form, especially in distant galaxies.
And on the really fundamental physics side, a new quantum gravity theory proposed, trying to link Einstein and quantum mechanics, and a new kind of time crystal. Sounds very abstract.
Highly abstract, but potentially revolutionary. A successful quantum gravity theory is kind of the holy grail of physics. And things like time crystals, these weird states of matter, they push our understanding of reality and could, down the line, have applications in things like quantum computing. Plus, the breakthrough prize in fundamental physics went to the LHC collaborations for the Higgs boson work, recognizing that massive achievement.
It's just amazing how it all connects, isn't it? From the biggest cosmic scales down to quantum weirdness, it's all part of the same puzzle we're trying to piece together.
Precisely. It's this period of intense discovery where observations and theory are constantly pushing boundaries, forcing us to question fundamental assumptions about the universe and its laws.
Okay, let's shift back within our solar system for a moment, but look beyond the Moon and Mars. What other fascinating tidbits did we learn about our neighbors?
Yeah, while the Moon and Mars get a lot of attention, there were some really cool insights into other bodies this quarter, revealing just how complex and dynamic our solar system is.
Like the Moon's ancient magnetism. That puzzle. A new theory suggests asteroid impacts could have created temporary magnetic fields.
Right. It's a clever idea. The Moon doesn't have a global magnetic field now, but lots of its old rocks are magnetized. So how? Big impacts early on could have generated intense, short-lived fields and plasmas, magnetizing the rocks before they cooled. It offers a plausible explanation.
And how planets form their cores. NASA had a study on alternative ways that might happen. Could change how we think about Earth's beginnings.
Potentially, yeah. Understanding core formation is fundamental to understanding rocky planets. Adding new mechanisms to the mix helps us build a more complete picture of those very early stages.
Even asteroids aren't simple. Vesta, one of the biggest, research suggesting it's more like a protoplanet with a missing core.
Yeah, that really challenges the view of Vesta as just a big rock. It suggests it had a much more complex past, differentiated internally like a small planet, but maybe something went wrong or it lost its core somehow. Fascinating idea.
And Titan, Saturn's weird moon, its atmosphere has a wobble, like a gyroscope.
Added to the list of Titan's weirdness, it suggests the thick atmosphere isn't perfectly coupled to the moon's rotation. Hints at complex interactions between the surface, maybe a subsurface ocean, and that dense atmosphere. More puzzles to solve.
And even in harsh radiation, the building blocks for planets can survive, like organic molecules.
That's a really important finding. Shows that even around stars blasting out lots of UV radiation, the raw materials for planets can persist. Broadens the range of places where planets like ours might form.
Jupiter, too. Its magnetic shield got squashed by solar wind. Uneven ammonia, maybe linked to ammonia hail. Hints it might have been bigger in the past. Plus, Europa Clipper's UV instrument is ready.
Jupiter just keeps revealing its dynamic nature, responding dramatically to the sun, weird weather patterns deep inside, clues about its ancient history. It's never dull. And yeah, the Europa Clipper's UVS instrument being commissioned is a key step towards exploring that potentially habitable icy moon. Ready for science.
It just shows, doesn't it? Our solar system is still full of surprises. Yeah. Every time we look closer, we find something unexpected.
Absolutely. Our understanding is constantly evolving with new data, better models. These findings just underscore how dynamic and, frankly, weird our cosmic neighborhood can be.
Okay, let's turn to maybe the biggest question of all. The search for life beyond Earth, and the work happening right here that supports both that search and future human exploration. Astrobiology.
It's a field moving incredibly fast, yeah. Q2 saw really interesting progress on multiple fronts, studying Earth analogs, understanding space health. It all connects.
That Arrakis project sounds cool. Studying microbes in frozen Alaskan sand dunes as stand-ins for Mars or Titan.
It's a brilliant approach, analog research. By seeing how life survives in these incredibly harsh, cold, dry, nutrient-poor places on Earth, we get clues about where and how life might exist in similar spots on other worlds. They had field research planned for March and late summer this year.
And for sending humans further out.
Yeah.
Understanding the health effects is critical. The Expand program collecting data from commercial spaceflight participants, that's a new angle.
It is. Gets data from a wider, more diverse group of people experiencing spaceflight, not just career astronauts. Helps understand the range of human adaptation, identify risks, develop countermeasures for those long trips to Mars someday.
We also heard about research into drugs to help with heart issues on long missions, studies on microbes, inside space habitats, how microgravity affects immune genes. Seems like we're constantly learning more about how space messes with us.
These studies are absolutely fundamental. We have to figure out how to keep crews healthy and performing well on missions that could last years. Understanding the physiological hits, the immune changes, it's paramount for deep space exploration.
And microgravity is still a useful tool for research itself, right? Redwire's contract to grow those high-value crystals on ISS for pharma.
Yeah, that potential for growing better crystals for drug development is still being explored. It helps understand protein structures, potentially leading to better medicines. We're also seeing growing interest in orbit manufacturing generally, like Redwire's work on bioprinting heart tissue, or studies like one on how Bacillus subtilis bacteria behave during a Chinese spaceflight. It's all part of figuring out how biology works off Earth.
It's fascinating how the search for alien life and enabling human life in space are so linked. Learning about Earth extremophiles informs the search, and space medicine tech often helps us back on Earth.
Exactly. Astrobiology is incredibly interdisciplinary now. Planetary science, microbiology, medicine, engineering. It all feeds together. The quest to understand life potential out there directly helps our own ability to explore.
All right, let's shift gears now to the engine driving a lot of this activity, the commercial space sector. Feels like this area is just exploding with innovation, new companies.
It really is. Just incredibly rapid expansion and innovation across the board. New launch services, massive satellite constellations, even space tourism starting to find its feet.
SpaceX is still the dominant force in launch, right?
Yeah.
Falcon 9's going up constantly, mostly for Starlink, including those new direct-to-cell sats. And Starship got FAA approval for its next big test flight.
Yeah, SpaceX's launch cadence is just relentless, driven mainly by Starlink deployment. And getting FAA approval for Starship IFT-9, targeting late May, shows their continued push towards that fully reusable, super heavy lifter. Their potential takeover of SLC-6 at Vandenberg would also seriously boost their West Coast launch capability.
Rocket Lab's holding its own in the small launch market, too. More Electron successes, like for IQPS, and making progress on their bigger reusable Neutron rocket. Seems like they're playing across different scales.
Definitely. Rocket Lab has nailed the small sat market with Electron. Neutron is their move into the medium lift game, aiming for reusability there, too. And their Photon spacecraft platform being chosen for Moon, Mars, even Venus missions shows their tech is versatile beyond just launch.
Blue Origin. New Glenn finally flew its first mission. Been a long wait for that one. Didn't get the booster back this time, but reaching orbit on the maiden flight is still huge. And New Shepard keeps flying tourists, including some celebs.
New Glenn's successful debut in January was a really significant step for Blue Origin and welcome competition in heavy lift. Getting to orbit first time out is a major engineering win, even without the booster landing. And yeah, New Shepard flew NS-31 in April with an all-female crew, including Katy Perry and Gayle King, and announced the NS-32 crew in May, still bringing that suborbital experience to paying customers.
ULA United Launch Alliance got their Vulcan Centaurs certified for those important national security launches. That's big for them, competing for government contracts.
Absolutely critical. NSSL certification allows Vulcan to compete head-to-head with SpaceX for those big Defense Department and intelligence agency launches. They've got USSF-106 and USSF-87 lined up, plus the first launch of Sierra Space's Dream Chaser spaceplane on a Vulcan. Big manifest ahead.
And lots of other players globally, right? ABL rebranding to focus on defense, Gilmore in Australia, RFA in Germany, aiming for first launches, and Space in China launching their methane rocket again.
Yeah, the launch market is definitely diversifying globally. You've got SpaceX and Rocket Lab leading on frequency and reusability focus. New Glenn and Vulcan entering the heavy lift fray. Others like ABL pivoting, showing how tough it is. And yes, Gilmore aiming for Eris-1, RFA, and Saxavord, prepping for the UK's first vertical launch. Landspace successfully launching Zoot 2 again and working on the bigger Zoot 3. It's a very dynamic picture. Reusability is still the name of the game for cutting costs.
Beyond launch, satellite internet. Starlink keeps growing. Amazon's Project Kuiper launched its first prototypes. That's a lot of satellites.
The race is definitely on. Starlink has over 7,000 birds up, working on V3 direct-to-cell. They have a huge head start. But Amazon launching its first 27 Kuiper prototypes in April, testing laser links, working Ka-band. They're a serious, well-funded competitor aiming for global coverage, pushing hard on regulatory fronts, like in India, too.
But LEO isn't just internet anymore, is it? Earth observation, specialized sats, Black Sky, ICEYE, Spire, Astronus, Apex, Muon. Lots of companies finding niches.
Absolutely. The LEO economy is diversifying fast. Black Sky launching more Gen 3 high-res sats with AI analysis. ICEYE using synthetic aperture radar, SR for things like missile defense, getting innovation awards, Spire winning big Space Force contracts, Astronus building small GEO sats, partnering in Taiwan, demoing resilient GPS, Apex deploying its first satellite bus, Muon launching weather and wildfire monitoring prototypes.
Wow.
It's a vibrant ecosystem. Specialized data, analytics, secure comms, critical for defense, intelligence, climate monitoring, disaster response. There's huge synergy between commercial innovation and government needs here, and the barrier to entry for new space applications keeps getting lower.
Even space tourism. Seems like different models are emerging. SpaceX with ultra-expensive private orbital trips like Fram2 over the poles, Blue Origin with regular suborbital ops, Virgin Galactic pausing flights to focus on their scalable Delta class.
Exactly. Distinct paths. Fram2 in April on Dragon was unique polar orbit science focus. Blue Origin offering fairly regular suborbital flights. Virgin Galactic reported lower Q1 revenue as they focus investment on the Delta-class ships, aiming for research flights in summer 2026, private flights fall 2026, reopening sales early 2026. So yeah, different price points, different experiences, targeting different segments of a market that's still very much emerging.
And all this needs money. Investment seems steady. Q1 saw about $1.6 billion into space tech startups. Notable rounds for Stoke Space, Loft Orbital, K2 Space.
Yeah, Q1 investment was solid, around $1.06 across 56 rounds over $200K, with 4 over $100. That follows a couple of years, around $6 plus globally. PitchBook tracked $9.01 in 2024, may be trending towards later stage funding. Stoke raising $260 for their reusable medium rocket using Launch Complex 14 is huge. Loft Orbital's $170 for space as a service. K2 Space's $110 for large satellite manufacturing shows where investors see value, reusability, services, scalable manufacturing.
Market sentiment seems maybe more cautious. Focus on actual revenue now.
Definitely maturing. More focus on solid business models, profitability paths. There are uncertainties, tariffs, geopolitics, AI's impact, public market volatility, potential U.S. spending cuts. But national security space startups are attracting VC interest, anticipating defense spending.
And mergers and acquisitions. Seeing consolidation.
The broader aerospace, defense, and government services sector saw robust M&A in Q1. Volume up, lots of strategic buyers, more cross-border deals, stable valuations for companies with unique tech. Overall, A&D deal volume was the highest since 2022, driven by global tensions, demand for munitions, space system surveillance. MDA Space in Canada had a strong Q1, revenue up 68%, backlog up 46%, and they acquired SatixFy to boost their satellite systems capabilities. So yes, strategic M&A is happening, building comprehensive solutions.
And finally, the tech itself, advanced propulsion. Nuclear, hypersonic, still pushing boundaries.
Always. Nuclear propulsion saw Space Nuclear Power Corp partner on fission tech. Pulsar Fusion pushing their Sunbird fusion rocket concept demo 2027, production early 2030s, but also looking at fission electric. Hypersonic saw DoD's second successful recoverable Talon A flight, Mach 5 plus MS. Rocket Lab is planning to launch a hypersonic scramjet test vehicle soon.
Even small-sat propulsion is getting fancy. Plasma thrusters with high efficiency.
Yeah, CUA's DUPLX CubeSat mission plan for H1 2025 aims to demo a fiber-fed pulsed plasma thruster, FPPT, with over 3,500 seconds specific impulse. It's really good fuel efficiency, and also a monofilament vaporization propulsion system, MVP. Swista 12 was testing electric thrusters too. Lots of innovation for keeping small sats maneuverable and sustainable in LEO.
In-space servicing, assembly, manufacturing, ISAM. That metal 3D printing on ISS was part of that.
Big part of it. Huge milestone. ISS National Lab had a funding call for ISAM tech, too. Starfish Space was planning its first commercial satellite docking demo around May 20th. ISAM is seen as crucial for building bigger things in space and maintaining existing assets.
In habitats, surface construction. Still focused on the Moon and Mars.
Definitely. NASA's LSI program, the Lunar Surface Innovation Initiative, saw progress with that EBS Dust Shield demo on Blue Ghost 1. They're funding tech for building things on the Moon and Mars. The Lunar Surface Innovation Consortium had its spring meeting, laying groundwork.
And life support, space health, continuing focus.
Absolutely. That EXPAND program collecting commercial astronaut data, pharma countermeasures research, studies on habitat microbes, immune effects. ISS National Lab's funding call included translational medicine, too. Keeping humans alive and well off Earth is fundamental to everything else.
So from fusion rockets to 3D printing metal in orbit, the tech underpinning all this is moving incredibly fast.
It has to. Nuclear propulsion could revolutionize deep space travel times. Reusable hypersonics have defense and maybe commercial applications. ISAM enables complex orbital infrastructure. Lunar surface tech and astronaut health are vital for Artemis and beyond. Technology is the absolute key enabler.
Okay, so with all this increasing activity, especially commercial, the need for rules of the road, governance, collaboration, that becomes even more important, right?
It's absolutely critical, and we saw continued efforts on that front in Q2.
The Artemis Accords seem to be gaining momentum. Norway signed on, Bangladesh, Finland. Brings the total over 50 nations now.
Yeah, Norway was the 55th signatory on May 15th. It shows this growing international alignment around basic principles for peaceful, sustainable lunar exploration. NASA held an international workshop on the Accords, too.
And lots of other agreements happening, too. Bilateral, multilateral stuff.
Tons of it. Space ISACs and NASA's SCAN network agreed to cooperate on space ecosystem security. The UK funded international partnerships. The UAE partnered with Firefly for that Rashid 2 rover we mentioned. Canada co-hosted the big Space Ops 2025 conference focused on sustainability. Australia and Canada signed an LRU. Russia even appointed Sergei Krikalev, the cosmonaut, as a special rep for international space cooperation.
So it's happening on multiple levels, broad principles like Artemis Accords and specific technical or info-sharing deals.
Exactly. It's this multi-layered approach. Leveraging commercial capabilities within national agency goals is also a big trend we saw, like with UA Firefly. It's a dynamic mix of overarching principles and focused partnerships shaping space governance.
But some big challenges remain. Space traffic coordination and management, STM. Just keeping track of everything up there.
A huge and growing challenge. NOAA's Office of Space Comments was very active. They spoke at the UN COPUOS meeting, expanded data sharing work with SpaceX for their TRAS-CSS system, sought industry input on buying space situational awareness data, held listening sessions. They're trying to get ahead of the curve, developing the U.S. civil STM system. There was also work on a draft ISO standard for space traffic coordination. It needs global cooperation.
And the flip side, space debris. Still a massive problem.
Getting worse, frankly. ESA released their Space Environment Report for 2025, highlighting the rapid increase in debris, LEO crowding, fragmentation events. They stressed the need for active debris removal, ADR, and stricter global mitigation, like maybe a 5-year deorbit rule instead of 25.
ADR actually going up and grabbing junk.
Yeah. ESA is pursuing their zero debris approach, planning the Clear Space One mission. But the existing voluntary UN guidelines lack teeth, and ADR faces legal hurdles too, like who owns the debris you want to grab. The UK Space Agency also reported high numbers of uncontrolled re-entries and collision alerts in March. It's urgent.
Then there's Space Resource Utilization, SRU, mining the moon or asteroids. Still figuring out the rules for that.
Very much so. Discussions continued at the UN COPUOS Legal Subcommittee in May. The U.S. reiterated its stance. SRU is consistent with the Outer Space Treaty, which doesn't forbid owning extracted resources, just celestial bodies themselves. They cautioned against rushing into binding legal frameworks now, favoring non-binding principles for transparency, open science, avoiding harmful interference, pointing to the Artemis Accords again. Others presented different legal models. It's complex, balancing national and commercial interests with preserving the space environment.
And space weather, keeping an eye on the sun's tantrums.
Yep. NOAA released results from their pilot program evaluating commercial space weather data sources. Integrating commercial data is key there, too.
So it seems the big themes in governance are needing global STM, the urgency of debris, the ongoing debate on resource rules with the U.S. favoring principles for now, and integrating commercial data.
That sums it up well. Multi-stakeholder cooperation is essential for STM. Degree needs action, not just talk. SRU requires balancing interests carefully, and commercial data is becoming vital across the board.
And beyond the big flagship missions, the national space agencies, NASA, ESAS, CNSA, JAXO, ISR, they were busy with lots of other stuff too.
Oh yeah, absolutely. NASA was working on tech for planetary cores, lunar Mars construction, testing the quiet supersonic X-59 jet, doing Earth science on volcanoes with SWOT data, learning from geomagnetic storms, running student launch competitions, awarding contracts, a huge range. ESA was dealing with budget implications from potential NASA cuts, preparing for their next ministerial council meeting, focusing on space safety asteroid detection, debris tracking, their Vigil space weather mission, even sending a CubeSat to asteroid Apophis. Plus, Earth observation work like prepping the EarthCare satellite.
China, CNSA.
Continued high launch cadence and reiterated that long-term goal for crewed Mars missions around 2050, mentioning the Long March 10 and Mengzhu again. Steady progress.
JAXAs in Japan.
President Yamakawa emphasized their lunar commitment, readiness to cooperate with the U.S. on resupply, landing tech, rovers, even sharing lunar water data, potentially with India. Very collaborative stance.
And ISRO in India had a setback.
Unfortunately, yes. Their EOS-09 Earth observation satellite launch failed on May 18th due to a third-stage malfunction on the PSLV rocket, a reminder of the risks. They also confirmed their Gaganyaan crewed launch is delayed to 2027, but astronaut Shubhanshu Shukla is part of that international Axiom 4 crew going to the ISS.
So a really diverse picture globally. NASA's broad scope, ESA's focus on safety and budget realities, China's independent long-term plans, JXA's collaborative approach, India pushing forward despite setbacks. It shows a complex ecosystem.
Exactly. Collaborative in many ways, but also competitive. Interconnected to ESA reacting to NASA's budget shows that. And yes, spaceflight remains inherently risky, as the ISRO failure reminds us.
So let's try and wrap this all up. Our deep dive into Q2 2025. Key themes seem to be this accelerated exploration on multiple fronts: Moon, Mars, beyond. A scientific renaissance driven by these amazing telescopes, a commercial space sector that's really maturing, finding its footing, a growing focus on governance, sustainability, the rules of the road, and underpinning it all, technology is the key enabler, constantly pushing what's possible.
That's a great summary. All these threads are weaving together, shaping our understanding of the universe and defining our future in space. It paves the way for, well, undoubtedly even more exciting discoveries and bigger steps in the years ahead.
And on that note, here's a final thought for you, the listener, to chew on. With all this increasing activity, all these new players, commercial and national, what do you think will be the single most pressing challenge we face in ensuring the long-term sustainability and peaceful use of space in the next decade?
That's a really important question. Definitely something to think about as we keep pushing outwards.
Thanks for diving deep with us today. Keep looking up.